Hello everyone, in this video I'm going to walk you through AP Precalculus free response question number 3. Task model A. A windshield wiper plate on a car window rotates back and forth. When the wiper plate is farthest to the left or farthest to the right, the measure of the angle formed by the wiper plate and the vertical center line. Here's the vertical center line. Is 0.75 radian, right? Which means this one is 0.75, right? At time t equals 0 seconds, the wiper plate is farthest to the left, right? So this one t equals 0. The wiper plate then rotates to the right and passes the vertical center line. At time t equals 1 seconds, the wiper plate is farthest to the right for the first time, alright? So when it goes over here, this is t equals 1, alright? Then the wiper plate rotates left, passes the vertical center line, and is farthest to the left again at t equals 2 seconds, okay? So when it goes back to the left, t equals 2. As the wiper plate rotates, the measure of the angle formed by the wiper plate and the vertical center line periodically increases or decreases. The sinusoidal function h models the measure of the angle in radians formed by the wiper plate and the vertical center line as a function of time t in seconds. A negative value of ht indicates the wiper plate is to the left of the vertical center line, alright? So to the left, h of t is negative, right? To the right, h of t is positive, so keep that in mind. A positive value of h of t indicates the wiper plate is to the right of the vertical center line. The graph of the function h and its dashed midline for 2 full cycles is shown below. 5 points F, G, J, K, and P are labeled on the graph. No scales is indicated, and no axes are represented. Determine possible coordinates of T, H of T for the 5 points F, G, J, K, and P. Alright, so we look at this one right here. We see that farthest to the left is going to be negative 0.75. Right? Because it says a negative value of h of t indicates the wiper plate is to the left, right? And farthest to the right is going to be 0.75, right? There you go right here. So here's negative 0.75 and this one is 0.75, right? This guy right here, the center line right here, this is the midline, right? Now, you can translate this one on the graph right here, right? So I'm going to go over here. The midline right here, it should be 0, right? The maximum is 0.75. The minimum is negative 0.75. Now, how do I know if the midline equals 0? Because I know that midline, which means D, equals mass plus mean divided by 2, right? So it could be 0.75 plus negative 0.75 divided by 2 is going to be 0, right? Now, we need to find the period. So, look, it starts from the left-hand side, right? It's go to the right-hand side at t equals 1 and go back to over here. So, the period should be 2 seconds, right? Now you're going to take the period divided by 4 to find the length of each quarter, right? So 2 divided by 4 is going to be 1/2, right? Or 0.5, right? So 0.5 is the length of each quarter, right? Point F is the maximum point, right? So the maximum value should be 0.75, you put over here, right? Which means the wiper plate should be on the right hand side right here, right? And right at this point, t should be equal 1, right? So I have 1 right here, right? When it's go to g, this is the midline, which means the first quarter, right? So you need to add 0.5 each time. Look, each quarter 0.5, right? So I have 1 right here at 0.5, which means 1.5 here, right? Midline, which means 0, right? Next one, I'm going to add 0.5, I get 2 right here, and it's going to be negative 0.75. I copy this one right here, over here, right? Next one, point K right here, you keep adding 0.5, so it will be 2.5, right? And this one is 0, right? And the next one should be 3, and this one should be 0.75. Alright, now I'm going to make sure to see if the period is equal to, right? So I look at this one, this is 3, this is 1. 3 subtract 1 equal to, yes, this is correct. Okay. Now, after you have the coordinate points of 5 points, you're going to move on to the next one. Question B right here, right? The function h of t is written as a sine b times t plus c plus d, right? Find values of the constant a, b, c, and d, right? Now, you need to answer the question right here. A, b, c, d right here, right? Now, again, you need to calculate a, which means maximum subtract minimum divided by 2, right? Maximum is 0.75, subtract minimum, which means subtract negative 0.75, and divide by 2, right? So a should be 0.75, right? Now, d is the midline, which means maximum plus minimum divided by 2. It's going to be 0.75 at negative 0.75 divided by 2. So it's going to be 0, right? Next one, you need to solve for b, right? b equals 2 pi divided by period, right? So it's going to be 2 pi divided by 2. It's going to be pi, right? Now the phase shift, there are infinitely many phase shift, right? So the answer varies, right? Depends on where you pick the phase shift. Now look, go back over here. If I start right here, okay, so right here should be 0.5, t equals 0.5, right? Because this one is 1, right? So this one should be 0.5. So I'm gonna go up, right? The sine function go up, and then a should be positive, right? So c right here is gonna be negative 0.5. Keep that in mind. If c equals negative, which means it's shift to the right. If c equals positive, it's shift to the left, right? Right here, you need to write a equals 0.75, b equals pi, c equals negative 0.5, and d equals 0. Alright, this is just one option. You have other options. Now, let's move on to question C right here. Refer to the graph of the function h in part A. The t-coordinate of the point G is t1, and t-coordinate of the point J is t2, right? On the interval t1, t2, which of the following true about the function h? Now, you need to locate point G and point J. Okay, so point G is going to be right here, and point J is going to be right here, right? So I need to label this interval. It's from here to here, okay? So the function h is positive or negative, increasing or decreasing. Now keep in mind, if the function is positive, it should be above the x-axis if you given a graph, or the y coordinate is positive if you given the coordinate. If it's negative, it should be below the axis if you given the graph, or the y coordinate should be negative, right? So since you're not given the graph, right, you given the coordinate points, right? So we look at the coordinate point, right? So it's going to be right here. The coordinate point is right here. The y coordinate point right here is less than 0, right? So it should be negative, right? So you need to eliminate A and B, right? Negative right here. Now, you look at this one right here, you see that the function is going down, right? If it's going down, the function is decreasing. So the answer must be D, because it's decreasing right here. Question C, 2i. On the interval t1, t2, describe the concavity of the function h and determine whether the rate of change of h is increasing or decreasing. Alright, so we look at this one right here. The function is concave up, right? Now you need to say the graph of the function h is concave up, right? And the rate of change is increasing, right? Because the function is concave up. Now let's move on to task model B. A sewing machine rapidly lowers and raises a threaded needle through a small slot in a steel plate. One full cycle consists of needle moving from its highest position to its lowest position and then returning back to its highest position. The needle completes 12 full cycles every second. Point B is at the bottom tip of the needle, right? So it's point B right here, right? This is point B on the tip of the needle. As the needle moves up and down, the height of the point B above the steel plate periodically increases or decreases. At time t equals 0 seconds, point B is located at its highest position, 9 millimeters, directly above the steel plate, right? So this one right here is the highest point, right? This one right here is the lowest point, right? And this one is the steel plate, right? So the distance from here to here is going to be -5, right? Distance from here to here is going to be 9, right? The sinusoidal function h models the height of the point being above the steel plate in millimeters at a function of time t in seconds. A positive value of ht indicates b is above the steel plate, right? So above the steel plate should be +9, right? A negative value of h of t indicates the point B is below the steel plate, right? So this one really must be -5, right? The graph of the function h and its dash midline for 2 full cycles right here is shown. 5 points F, G, J, K, P labeled on the graph. No scale is indicated and no axis presented, right? Determine possible coordinates of the 5 point F, G, J, K, and B, right? Now look at this one right here. We need to locate the maximum, minimum, and midline first, right? So maximum should be 9 right here, right? So we put 9 right here. This is the maximum. Minimum should be -5, right? Now midline equals the average of maximum and minimum, right? So 9 plus -5 is going to be 4. 4 divided by 2 is going to be 2. So the midline equals 2, right? Now we need to find the period first, right? So the period equals times divided by number of cycle, right? Or rotation. So keep that in mind. Time is going to be right here, 1 second, right? 1 divided by 12, right? Because we have 12 full cycles right here, right? So this one is going to be 1/12 seconds. Now you need to divide this guy by 4, right? So 1/12 divided by 4 is going to be 1/48, right? So each quarters has 1/48 seconds, right? Now, at time t equals 0, point B is located at its highest position, which is 9, right? So right here, t equals 0, right? This is the highest position. Now, its quarters has the length 148, right? So you just put 148 here, right? And then the coordinate should be 2, right? Right here, t equals 0, I'm going to put 9, right? So t equals 0, h of t equals 9, right? 9 here. Now, you keep adding 148 each time, right? So this one should be 2 over 48. And then the y coordinate should be -5, right? -5. Now this one should be 3 over 48, right? And then the coordinate of y should be 2. And point B right here is going to be 4 over 48, 9, right? You can simplify this one. 2 over 48 should be 1 over 24, right? Now 3 over 48, which means 1 over 16, right? And this one, 4 over 48, which means 1 over 12, right? Now let's move on to question B. We need to solve for A, B, C, and D, given the function h of t equals A cosine B of t plus C plus D. Now you know that the cosine function starts from the maximum, back down to the midline, go down to the minimum, back up to the midline, and go up to the maximum, right? If it starts from the minimum, the function looks like this. Alright, now for the first case right here, A is positive. The second case right here, A is negative. So keep that in mind. Alright, go back over here. We need to solve for A, B, C, and D, right? So recalculate A. A is going to be mass subtract mean divided by 2. So it's going to be maximum equal 9. Minimum is -5, right? So 9 subtract -5 divided by 2. It's going to be 7, right? Now you need to find the midline. Midline equals mass plus mean divided by 2. So it's going to be 9 minus 5 divided by 2. It's going to be 2, right? You need to solve for B. B equals 2 pi divided by period, right? Period equals 1 over 12, right? So you just multiply the top and bottom by 12, right? Like this. So this one cancel out. So it could be 24 pi, right? Now, the next one, you need to find the phase shift C. So we look at this one. The cosine function, you can start right here, right? If you start right here and you go down like this, right? Which means A positive, right? Look at the graph right here, okay? So if you start right here, the phase shift is 0, right? So C equals 0, right? So right here you can write A equals 7, B equals 24 pi, C equals 0, and D equals 2, right? Now, you have another option. Remember, B still 24 pi, right? D still 2, right? Now A and C could change. Now, you need to pick the phase shift, right? So if you start right here, remember the cosine function either start from the maximum or minimum, right? If it starts right here, the phase shift right here should be 124, right? The phase shift right here should be -124, right? So C right here is -124 right here, right? Now, because it starts right here and it go up, right? If it go up, it looks like a graph right here. A should be negative, right? So A in this situation should be -7, right? Now, next one. B still the same. D still the same, right? Now A and C could change, right? Now, if you start right here, right? The phase shift is -1 over 12. So C equals -1 over 12, right? And then you go down, right? So you look at the graph of the cosine function right here. A should be positive, right? So A in this situation is 7, right? Now let's move on to the next question right here. Refer to the graph of the function h in part A, right? T1 is the coordinate of the point F. T2 is the coordinate of point G, right? So I need to locate this one right here, F and G, right here. Alright, now you need to answer the question. Is the function positive or negative? Decreasing or increasing? So we look at the y coordinate right here. We see that the y coordinate is positive, right? So the function is positive, right? You need to eliminate C and D, right? Function is positive. Now, because the function is going down, which means it's decreasing, right? So decreasing right here, the answer must be B, right? Now, we need to determine the concavity and the rate of change of the function, right? The concavity, the function is concave down, right? And then the rate of change is decreasing because the function is concave down, right? So you need to say the graph of the function h is concave down on the interval t1, t2. And the rate of change of the function h is decreasing on this interval, right? Alright, let's move on to the next question. The task model C. The figure shows an overhead view of a canoe, with its paddles extended out on both sides of the canoe. Point A and B are at the end of each paddle. As the occupant in the canoe rows, the position of the two paddles moves from position 1 to position 3 before returning back to position 1. At both position 1 and position 3, the distance between A and B is 5 feet. So the distance from here to here is 5 feet, right? This guy is 5 feet, right? So the position 1 and position 3 right here have the minimum distance, right? The greatest distance between A and B occurs at position 2, where A and B are 6 feet from the dash center line of the canoe. Alright, so means this one is 6, this one is 6, so total should be 12. So 12 is the maximum distance, alright? At time t equals 0 seconds, the paddles in the position 1, the paddles then rotate through position 2 to position 3. At time t equals 3 seconds, the paddles reach position 3 for the first time, right? Then the paddles rotate and reach position 1 again at time t equals 6 seconds. As the occupant paddles, the distance between A and B periodically increases and decreases. Alright, so from this information, we can conclude that the period equals 3 seconds. Alright, be careful. A lot of students make mistake. They're gonna say t equals 6 seconds. That's not the case, right? Look at this one. At t equals 0, the paddles are in position 1, which means at the minimum, right? And then the paddles rotate through position 2 to position 3. At time t equals 3 seconds, the paddles reach position 3 for the first time, right? So you see that it's minimum right here. It's go back to the minimum. So the period must be 3. The sinusoidal function h models the distance between A and B in feet as a function of time t in seconds. Alright, now we need to find the coordinate points of point F, G, J, K, and P, right? Now we just analyze that the maximum should be 12, right? The minimum should be 5, right? And then the midline is equals maximum plus minimum divided by 2. So 12 plus 5 equals 17 divided by 2. It could be 8.5, right? Now, At time t equals 0 second, the paddles are in position 1, right? Position 1 is minimum values 5, right? So, before this one, we need to extend this one to the left to see what happens, right? Now, we look at this one right here. At time t equals 0 second, the paddle in position 1, so position 1 right here at the minimum value. This is t equals 0, right? This point right here, t equals 0.75, right? Because you see that period equals 3 seconds, right? So 3 divided by 4, you will get the length of each quarter, right? It's going to be 0.75. This is the length of 1 quarter, right? Alright, so next one right here, at the maximum point, right, t equals 1.5. Now next one, this one, you keep adding 0.75. So this one, t equals 2.25, right? And point J right here, t equals 3, right? Point K right here, t equals 3.75. And point P right here, t equals 4.5. Alright, period is the distance of the S value between two maximum or two minimums. Now we're going to check it. This one is 1.5. This one is 4.5. 4.5 subtract 1.5 is going to be 3. Yes, that's correct, right? This one is 0. This one is 3. Yeah, 3 subtract 0 equals 3, right? Alright, now we're going to go over here. We need to write the coordinate points, right? Point F right here should be 1.5, comma 12, right? Point G, it should be 2.25, comma 8.5. Point J should be 3, comma 5. Point K should be 3.75, comma 8.5. And point P should be 4.5 and 12, right? Now let's move on to question B. The function h can be written in the form of a sine b times t plus c plus d. Find the values of a, b, c, and d. Alright, so we go over here. We need to answer the question B right here. Amplitude equals maximum subtract minimum divided by 2, right? So it could be 12 subtract 5 divided by 2. Right, it's going to be 3.5, right? Now, the midline D equals maximum plus minimum divided by 2. So it's going to be 12 plus 5 divided by 2. It's going to be 8.5, right? Now, next one, we're going to calculate B. B equals 2 pi divided by period. Period equals 3, right? So it could be 2 pi over 3, right? Now, C is the phase shift, right? Now, we look at this one. We can start from here, right? Or here, right? Now, if we start from here, which means t equals 0.75, right? So, which means we shift to the right 0.75, right? So, c equals negative 0.75. Keep in mind, when you shift to the right, c is negative. Shift to the left, c positive. Alright, so the answer right here, A equals 3.5. D equals 8.5. B equals 2 pi over 3. And C equals negative 0.75, right? Now, we have other option. Option 2. A equals 3.5, right? D equals 8.5. B equals 2 pi over 3. Now we're going to pick a phase shift. If we start from here, right, which means we shift to the right 2.25, right? So C equals negative 2.25. Now we see the graph of the sine function is going down, which means there is a reflection, right? Remember, the general form of the sine function is going to be go up, right? Like this. Now there is a reflection, it's going to be like this, right? So in this situation, A greater than 0. This one, A less than 0, right? So this going down, which means A negative. So you need to put the negative side right here. If you pick this phase shift, negative 2.25, right? Now you have another option. You still have A equals 3.5, D equals 8.5, B equals 2 pi over 3, right? Now C equals, if you stop right here, right, which means you shift to the right 3.75 and the function go up, which is this guy right here. So A is positive and C equals negative 3.75, right? So this one negative 3.75 and A stay the same, right? Now, let's move on to the next question. Refer to the graph of the function h in part A, right? Given the t1 as the t-coordinate of point G and t2 as the t-coordinate of point J. On the interval t1, t2, which of the following is true about the function h? Now, in order to know if the function is positive or negative, if the function is positive and you given the coordinate point, the y values of the coordinate must be greater than 0, right? If you given the graph, it must be above the x-axis. Now, if the function is negative, the y coordinate should be less than 0. The graph should be below the axis, right? Look at this one, you see that the coordinate point given, right? So we're going to use this guy right here. Now we need the function to be positive, right? So the y coordinate must be greater than 0, right? If we need the function negative, the y coordinate should be less than 0. Now we look at this one right here, we see that the y coordinate right here is 8.5 and 5. This is positive, right? The function is positive, right? So we go back over here. The function is positive, so you need to eliminate C and D because it's a negative, right? Now, look at this one, we see that the function is going down, which means it's decreasing, right? So the answer must be B. Let's move on to the next question right here. On the interval t1, t2, describe the concavity of the function h and determine whether the rate of change of the function h is increasing or decreasing. So we look at this one right here. The function is concave up, right? And then the rate of change is increasing because the function is concave up, right? So you need to explain it right here. Let's move on to the next question. Model D. A miniature golf course includes one hole that requires players to hit the ball through an opening in a large structure, while a windmill rotates in front of the opening. The figure shows a windmill rotating in a clockwise direction that completes one rotation every 20 seconds. Alright, so this one right here is the period. Remember, the period equals time divided by number of rotation. Alright, so in this situation, it's going to be 20 divided by 1. So it could be 20 seconds. Point B is on the tip of one of the windmill plates. Point S, which does not move, represent the top of the opening in the structure. As the windmill blades rotate at a constant speed, the height of B above S periodically increases and decreases. At time t equals 0 seconds, point B is at the lowest position. 2 feet directly above S. So this is the highest position, right? Point B go over here, right? The sinusoidal function h models the height of B above S in feet as a function of t in seconds. A positive value of h of t indicates B is above S, and negative values of h of t indicates B is below S, right? Now we need to find the coordinate points of 5 points F, G, J, K, and P, right? Now you need to find the maximum, right? The maximum is 10, right? The minimum is -2, right? So we're gonna put this guy right here. It's gonna be 10. The minimum is -2, right? The midline is maximum at minimum divided by 2. So 10 subtract 2 divided by 2 is gonna be 4, right? Now, at time t equals 0 seconds, point B at its lowest position. So point B is right here when t equals 0, right? Now we look at this one. This is the highest point, right? It's not the lowest point, right? So you need to extend this one to the left to see the graph clear, right? So it's going to be like this. Alright. So t equals 0, point B is right here. This is the lowest point. T equals 0. Alright, you know that the period equals 20, right? So then you take 20, you divide by 4 to get the length of each quarter, right? So 20 divided by 4, you get 5 seconds, right? So every single quarter, you're going to add 5, right? So this one, t equals 0, go over here. T equals 5 seconds, right? Now, point F right here, t equals 10 seconds, right? Because you're going to add 5, right? And the height right here is 10, so it should be 10, 10, right? Now, right here, point G should be 15 seconds, right? And then the height right here should be 4, right? It's going to be right here. Now, point J right here, it should be 20 seconds, right? And the height should be -2. Point K right here should be 25 seconds, right? And the height should be 4, right? Point P right here, you keep adding 5, it should be 30 seconds, right? And the height should be 10. Now let's move on to the next question right here. Question B. The function h can be written in the form of h of t equals a cosine b of t plus c plus d. We need to find a, b, c, and d. Alright, so to calculate a, we're going to use the formula maximum subtract minimum divided by 2. Alright, you know that the maximum is going to be 10. Subtract minimum should be -2 divided by 2. So it's going to be 6, right? Now, b equals 2 pi divided by period. The period equals 20 seconds, right? So it could be pi over 10. Now, c is going to be phase shift, right? So we look at this one right here. This is the cosine function, right? So you know that the cosine function starts from the maximum or minimum, right? If it's maximum, it's going to be like this. If it's minimum, it's going to be like this. Alright. Now we look at this one right here. We can start the function right here. Right? Right here. Or right here. Right? Point F, point J, or point P. Right? So we have three options. Right? Now if I start the function from point F, right? Which means I shift to the right 10 units. Right? So I have C equals negative 10. Right? Since you start from the maximum, A should be positive, right? If you start from the minimum, A is negative, right? So here's the answer. Now D equals maximum at minimum divided by 2. So it's going to be 10 plus negative 2 divided by 2. It's going to be 4. So I'm going to put the answer right here. A equals 6. B equals pi over 10. C equals negative 10. And D equals 4. Now we have other options. A still 6. B still pi over 10. D still 4, right? Now I'm going to pick the phase shift C. If I start right here, point P right here, still maximum, right? So C should be negative 30, right? And since I start from the maximum, A should be positive. So A remains unchanged, right? Now another option. A equals 6. B equals pi over 10. D equals 4. Now see, if I pick the phase shift right here at point J, right? Which means I shift to the right 20 units, right? So C equals negative 20. Because point J is the minimum value, right? So when I start from the minimum value, A should be negative, right? So right here, I need to change the sign of A, right? So A right here must be negative 6. Alright, so keep that in mind. Now let's move on to the next question. Alright, similar to the previous one, we look at the coordinate of point K and point P, right? So the graph should be right here, point K and point P. It's going to be right here. We need to identify within this interval, the function is positive or negative, right? So we look at the y-coordinate, right? The y-coordinate right here is going to be 10 and 4. So the function is positive, right? So we need to eliminate C and D. Now, since the function is going up, so it should be increasing, right? So the answer must be A. Now, let's move on to this question. We need to describe the concavity of the function h and the rate of change within this interval, right? Now, within this interval, the graph of the function is concave down, right? And the rate of change of the function should be decreasing, right? Because the function is concave down, right? Alright, now let's move on to the next question, task model E. The figure shows a man running inside a giant hamster wheel with an outer diameter of 8 feet, right? So diameter is right here from here to here. It's gonna be 8 feet, right? As the man runs, the wheel rotates in a clockwise direction, completing 2 rotations every second, right? So you know that the period equals time divided by number of rotation, right? Alright, so it's gonna be 1 second divided by 2 rotation. So it could be 1/2 seconds, right? Now, at time t equals 0 seconds, point S is located directly above the center, right? So the center is right here, point S right here. Of the hamster wheel, 2 feet from the ceiling above the hamster wheel, right? So the distance from here to here is gonna be 2 feet, right? As the man runs inside the hamster wheel, the distance between point S and the ceiling periodically increases and decreases. Alright. So you need to compare the distance from point S to the ceiling, not the floor. So keep in mind, it's going to be opposite. So in this situation, point S becomes the lowest point, right? This one is the lowest point. The point right here is the highest point. Now, the sinusoidal function h models the distance between point S and the ceiling in feet as a function of time t in seconds. Alright, now we need to find the coordinates of point F, G, J, K, and P. Alright, first we need to find the maximum and the minimum, right? And the midline, right? The maximum is right here, right? Which means 8 plus 2, right? It's going to be 10, right? So I write over here, this guy should be 10 maximum. Now, the minimum should be from here to here. So it could be 2 right here, right? So minimum is 2. Now, the midline is 10 plus 2 divided by 2. It's going to be 6, right? Now, at time t equals 0 seconds, point S is located directly above the center, right? Point S right here, right? So at time t equals 0, point S is the lowest point, right? Now look at this one right here, point F right here is the highest point, right? So we need to extend this one to the left to see how the function looks like, right? Okay, so right here t equals 0 and this is the point S, right? Because the distance from here to here is the minimum, right? Now, since the period equals 0.5 seconds, right? You need to take the period divided by 4. So it could be 1/2 divided by 4. It's going to be 1/8, right? So every single time you just keep adding 1/8, right? So right here is t equals 1/8, right? Right here 1/8 plus 1/8 is going to be 2/8, and you simplify it's going to be 1/4, right? And then the height should be 10. Now this one 2/8 plus 1/8 is going to be 3/8, right? This one is 4/8. This one is 5/8. This one is 6/8. Now you simplify 4/8, which means 1/2, right? So I put 1/2 right here. This is 5/8, cannot be simplified. This is 6/8, which means 3/4, right? And then you put the height here. This one should be 6. This one should be 6. This one lowest point, so the height should be 2, right? This one 2, and this one should be 10 right here. Now, on the AP exam, you don't need to simplify this one, alright? So you just keep adding 1/8 each time. So you just leave it like this. This is 1/8. You just put this one is 2/8. This is 3/8. This is 4/8. This is 5/8. This one 6/8. You still get full credit. Now let's move on to the next question. The function h can be written in the form of h of t equals a cosine b t plus c plus d. We need to find a, b, c, and d, right? So, to find a, it's going to be maximum subtract minimum divided by 2. Alright, maximum you know that 10, subtract minimum is going to be 2 divided by 2. So it could be 4, right? Now, the midline D equals maximum plus minimum divided by 2. So it could be 10 plus 2 divided by 2. It's going to be 6, right? Now, you need to find B equals 2 pi divided by period, right? So it could be 2 pi divided by 1/2, right? So you need to simplify this one by multiplying the top and bottom by 2 because I see 2 right here, right? So 2, this guy cancel out. The answer should be 4 pi, right? Now, the phase shift, there are multiple answers for the phase shift, right? Now, because this is the cosine function, so you either start from the maximum point F right here, point P right here, or you start from the minimum right here. And again, if you start from the maximum, the value of A should be positive. If you start from the point J right here, which means minimum, the value of A should be negative. So keep that in mind. So if I pick the point F right here at the starting point, right? So I shift to the right 1, 4, right? So C equals negative 1, 4, right? And A still positive, right? So I put the answer right here. 4, B equals 4 pi, right? D equals 6, and C equals negative 1 over 4, right? Now you have other options. Alright, A still 4, D still 6, B still 4 pi. Now, C is the phase shift, right? If you pick the starting point right here, point P right here, right? So which means you shift to the right 3, 4, right? So C equals negative 3, 4, right? And then A still the same, right? Because this is the maximum, right? Now, the last option right here. A equals 4, D equals 6, B equals 4 pi, right? If you pick the phase shift right at this point J right here, which means you shift to the right 1/2, right? And then this is the minimum point, right? C equals negative 1/2. So, since this one is the minimum point, A must be negative, right? So keep that in mind. Now let's move on to the next question right here. Alright, same thing. We look at the interval from T1, T2 of the point F and point G, right? So point F right here and point G right here, this interval. Alright, because the y coordinates are positive, so the function is positive, right? And then it's going to be decreasing because it's going down, right? So the function is positive and decreasing. The answer must be B, right? Now within this interval, the graph of the function is concave down, right? And the rate of change is decreasing, right? Let's move on to the next question. Task model F. The figure shows a figure skater as she performs a camel spin. The skater spins in a circular counterclockwise direction around her center of rotation and completes 6 rotations every second. Alright, so this one tells us that the period equals 1 over 6, right? Time divided by number of rotation, right? The distance between the center of rotation and a wall to the left of the skater is 18 feet and does not vary, right? So the distance right here, 18 feet. right? This one is the center of rotation, is the vertical line right here, and this one is the world. This one is 1/6 seconds, right? Now, point B right here is on the tip of her ice skate and is always 3 feet from the center of rotation. Alright, so the distance from here to here is gonna be 3, right? As she spins at a constant speed, the distance between point B and the world to her left periodically increases and decreases. At time t equals 0 seconds, point B is its farthest the distance from the world. So if this one is the farthest distance, which means it's gonna be 18 plus 3 equals 21 feet, right? This one is the maximum height, right? The sinusoidal function h model the distance between point B and the world in feet as a function of time t in seconds. Alright, now we need to find the coordinate of point F, G, J, K, and P. Now, the maximum is 21 feet, right? So this one is 21. Now the minimum, when the point P go over here, right? So this one is 3, right? So minimum should be 18 subtract 3, right? The distance from here to here is the minimum. Alright, it's gonna be 18 subtract 3. It's gonna be 15, right? So the minimum should be 15. Now the midline, maximum at minimum divided by 2. So it's gonna be 18, right? So right here you just put 21, right? This one is 18. This one is 18, right? And this one should be 15. Now, you know that the period equals 1/6 seconds, right? Now, you check the period divided by 4. So, each quarter has the length of 1/24 seconds, right? Now, at t equals 0, point P is farthest, right? So, look at the counterclockwise direction right here. At t equals 0, point P is right here, right? B right here, and this one t equals 0, right? Now, and this is the highest one, right? Because the distance from here to here should be 21, right? So right here, this is actually point F, and this one t equals 0, right? Now, when point B goes over here, right? Which means point B is on the center of rotation, right? So each quarter is going to be 1/24 seconds, right? So the distance from here to here is going to be 18, right? Now, this one right here, 18. And then the time should be 1/24. Now you keep adding 1/24 each times, right? So this one should be 2/24, right? This one 3/24. And this one is 4/24, right? You either leave your answer like this or you can simplify this, right? Now this one I can simplify, it's going to be 1/12, right? This one should be 1/8. And this one should be 1/6, right? Now let's move on to the next one. The function h can be written as h of t equals a sine b of t plus c plus d. We need to solve for a, b, c, and d, alright? So we're gonna go over here. Now a equals maximum subtract minimum divided by 2, right? Maximum is 21, minimum is 15, right? Divided by 2. So it's gonna be 3, right? Now, the midline D equals maximum at minimum divided by 2. So it can be 21 plus 15 divided by 2. It's going to be 18, right? Now you need to solve for B. It's going to be 2 pi divided by period. Period equals 1/6, right? Now you need to multiply the top and bottom by 6, right? So the answer is 12 pi, right? This one cancel out. Now you need to solve for C. C is the phase shift, so there are multiple values of C, right? Now you know that the function is sine, right? So the sine function starts from the midline, right? You can pick the points right here, or right here, right? So if I start right here at point G right here, right? Which means I shift to the right 1 over 24, right? So C should be negative 1 over 24, right? And then, since I start right here, it's going down. If it's going down, A should be negative, right? So I need to change the value of A right here, should be negative 3, right? So A equals negative 3, B equals 12 pi, C equals negative 1 over 24, and D equals 18. Now, let's move on to another option, right? We have multiple options for A, B, C, D, right? Now, A equals 3 again, D equals 18 again, and B equals 12 pi. Now, if I pick the phase shift right here, right? Does that mean T equals negative 1 over 24, right? Because the length of each quarter is 124, right? If I add 124, it's going to be 0 right here, right? So this one, I shift to the left, right? If I shift to the left, C equals 1 over 24, right? And then right here, I'm going to go up, right? If I go up, A should be positive, right? So I don't need to change the sign of A right here, right? So this is another option. Now, let's move on to the next option. If I start from K, right, which means I shift to the right 1 over 8, right? So C equals negative 1 over 8, right? A equals 3, right? Because from point K, I'm going to go up, right? So it should be positive. B and D should be the same, right? D equals 18 and B should be 12 pi, right? So these are 3 possible answers for question 3B, right? Now let's move on to question C. Now we need to look at the point G and point J and the coordinate T1 to T2, right? Point G to point J is going to be this interval right here. Alright, within this interval, the y values right here is positive, right? So if the y value is positive, the function is positive, right? And then the graph of the function is decreasing because it's going down, right? So right here, it should be positive and decreasing. The answer must be B, right? Now question C2I. On the interval T1 to T2, the function is concave up, right? And the rate of change is increasing, right? On the interval T1, T2, the graph of the function h is concave up, and the rate of change of the function is increasing, right? Contestant on the popular game show The Price is Right take turns spinning a large wheel to see who can see closest to $1 without going over. A pointed indicator, which is the red one right here, is positioned at the center of the wheel that is 8 feet in diameter, right? So the wheel has diameter of 8 feet. point S is on the outside edge of the wheel. So this is point S. To ensure the wheel is working properly, the producers of the show perform a series of test spins. A motor spins the wheel in a counterclockwise direction, completing one rotation every 8 seconds. This one tells us that the period equals 8 seconds, right? Because the period equals time divided by number of rotation. So keep that in mind. As the wheel spins at a constant speed, the height of the point S above the pointed indicator periodically increases and decreases. At time t equals 0 seconds, point S is at the same height as the pointed indicator, right? So this one right here is t equals 0, and this is the point S, right? The sinusoidal function h models the height of the point S above the pointed indicator, in fit as a function of time t in seconds. Positive values of h of t indicates S is above the pointed indicator, and negative values of h of t indicates S is below the pointed indicator. Alright, so we look at this one right here. We have 4 points right here, right? This one is the highest point, and this one above indicator, right? You know that the diameter is 8, right? Divide this one is, the midline is right here, right? So does that mean the distance from here to here is going to be 4, right? So this one right here should be positive 4, right? Now the lowest point should be right here, and this one should be negative 4 because it's below the pointed indicator, right? We have the period is 8 seconds, right? So you need to take this one divided by 4 to get the length of each quarter, right? So each quarter has 2 seconds, right? Per quarter. Alright, so this one is t equals 0. This one t equals 2. This one t equals 4. This one t equals 6. The height is 4, right? The height right here is 4. The height right here is 0 because it's on the midline, right? This one's still 0, right? Now this is t equals 6. Go back over here. T equals 8. T equals 10. T equals 12. And t equals 14, right? Now we go over here. We need to complete the graph right here. We know that the maximum is 4, right? The minimum is negative 4, and the midline right here is 0, right? So we just put the coordinate of the y value over here, 4, 4, 0, 0, and this one is negative 4, right? Now, this one is the highest point, right? So we look at this one, the highest point right here, and we know that we start from here, and then t equals 0 right here. So go over here, t must be equal to 6, right? Because this is 0, this one is 2, this one is 4, and this one is 6, right? Because you need to add 2 each time, right? Each quarter has 2 seconds, right? So right here, t equals 6, right? Now you keep adding 2 each time. This is 6, this should be 8, this should be 10, this should be 12, and this should be 14, right? So we're done with the first one right here. Now let's move on to the second one. We need to solve for A, B, C, and D, right? Now A, which means maximum subtract minimum divided by 2. So it's going to be 4 subtract negative 4 divided by 2. So it's going to be 4, right? Now we need to find the midline. D equals maximum plus minimum divided by 2. So it's going to be 4 plus negative 4 divided by 2. It's going to be 0, right? Now next one, we need to solve for B, right? B equals 2 pi divided by period, right? Period equals 8 seconds, right? So it could be pi over 4, right? Now, the last one, we need to find the phase shift, right? There are multiple values for the phase shift, right? Now, depending how you choose where's the function starts, right? The function h can be written in the form of h of t equal a sine of b times t plus c plus d, right? So this is the sine function, right? The sine function starts from the midline, right? So you're gonna either pick the starting point right here, or right here, right? Now, if I pick the starting point right here, does it mean t equals 4, right? Because this one is 6, this guy must be 4, right? 2 seconds before this one, right? So I need to shift to the right 4 units, right? So right here, c equals -4, right? We start right here and we going up, right? If you go up, a should be positive, right? Because the sine function is going to be like this, a positive, right? If it go down first, it should be negative, right? So a should be negative right here, right? Then your answer should be a equal 4, b equal pi over 4, c equal -4, d should be 0, right? Now you have other option. A equals 4, right? B equals pi over 4, right? D equals 0, right? Now see, if you pick the starting point right here, and then you shift to the right 8, which means C equals -8, right? And you go down first, right? If you go down, A should be negative, right? So right here, A should be -4, right? And C should be -8, right? Now you have another option. A equals 4, B equals pi over 4, D equals 0. Now see, if you pick the starting point right here, you shift to the right 12 units, right? So C equals -12, and you go up first, right? If you go up, A should be positive, right? So A remains unchanged, right? C equals -12, right? Now let's move on to question C. Refer to the graph of the function h in part A, right? The t coordinate upon j t1 and t coordinate upon k is t2, right? We need to determine if the function is positive or negative, increasing or decreasing, right? So point j to point k, right? So we refer to the graph right here. J to k is going to be this guy right here, alright? And we look at the y value right here, we see that the y value is negative. So the function is negative and it's going up, which means it is increasing, right? So negative and increasing, the answer must be C, right? Now on the interval t1, t2, the function is concave up and the rate of change of the function is increasing, right? So concave up and the rate of change is increasing, right? So you need to write the answer for this question in a complete statement, like what I did in the previous example, right? Now let's move on to the model H right here. Now the model H is similar to the model G, right? The only thing different right here is the period right here, right? 2 rotation every seconds, right? Which means the period equal time divided by number of rotations. So which means 1/2 seconds, right? So you need to take this one divided by 4. So each quarter has the length of 1/8 seconds, right? Now, at time t equals 0 seconds, point S is at the same height as the pointed indicator. So right here, t equals 0, right? And this one is the counterclockwise direction, right? Now the distance from here to here should be 5 feet, right? When point S go over here, this one is t equals 1 over 8 seconds, right? Because each quarter has 1 over 8 seconds, right? Now point S go over here, t should be 2 over 8, right? When point S go to the highest point right here, t equals 3 over 8, right? This one, t equals 4 over 8. And then go back over here, t equals 5 over 8, right? This one, t equals 6 over 8. This one, t equals 7 over 8. This model is slightly different from the previous model about the height, right? The height from the midline to the bottom is 5 feet, right? Which means the distance from the lowest point right here to the floor right here is 1 foot, right? So you need to be careful, right? The distance from here to here is going to be 4, right? The distance from here to here is going to be 4, right? Now when point S is at the highest point, this is the maximum value, right? It should be 9, right? Because 8 plus 1 right here. Alright. Right at this point, this is the midline, right? It should be 5, right? The height is 5. The lowest point right here should be 1, right? Right here should be 5, right? This should be 9. So the maximum height should be 9. The minimum height should be 1. The midline should be 5. Alright, so you need to be careful. So 9 should be right here. This guy should be 5. This guy should be 5. And this guy should be 1. Alright, we know that the period equals 1 over 2 seconds, right? And then each quarter, it should be 1/8 seconds, right? So you keep adding 1/8 each time, right? Now, point F right here is the highest point, right? But t equals 0, point S is at the midline, right? So, next one, this one, t equals 1 over 8. Point S go to the minimum, right? Next one, t equals 2 over 8. Point S go back to the midline. It's still not the highest point, right? And then the highest point right here, t equals 3 over 8, right? So you need to put 3 over 8 right here. Now you keep adding 1 over 8 each time, right? This one is 4 over 8. This one is 5 over 8. This one is 6 over 8. This one is 7 over 8. Now, if you want to simplify it, that's fine. If you don't want to simplify it, you don't need to. So I just leave it like that, right? Right here, I need to solve for A, B, C, and D, right? Now, I look at this one right here. The function is represented as the cosine, right? So, I have A equals maximum subtract minimum divided by 2. Maximum is 9, subtract minimum is 1, divided by 2. It's going to be 4, right? And B equals 2 pi divided by period. It's going to be 1/2, right? So I multiply the top and bottom by 2. So this one cancel out. It's going to be 4 pi, right? Now, I'm going to move on to D first, right? The midline is going to be mass plus mean divided by 2. So it could be 9 plus 1 divided by 2. So it could be 5, right? Now, C right here. Since this is a cosine function, so I have the option right here and right here, or right here, right? If I stop right here, which means I move to the right 3 over 8 units, right? So C equals negative 3 over 8, right? Now, since I start from the maximum, right? Which means I should be positive. Look at the cosine function right here. If it start from the maximum, I should be positive, right? If it starts from the minimum, A should be negative, right? Like this. A is negative, right? Alright, so I have one option right here. A should be 4, B should be 4 pi, D should be 5, and C should be negative 3 over 8. Now I have two more options. Remember that you have infinitely many options, right? So I have two more options. So I'm going to start from this point right here, point J, the minimum, right? So I shift to the right 5 over 8, right? Because I start from the minimum, A should be negative, right? So C equals negative 5 over 8. And A should be negative, so A equals negative 4. B equals 4 pi. And D equals 5, right? B and D's always remain unchanged, right? Now I have another option right here. If I start from here, maximum, right? I shift to the right 7 over 8 units, right? And then A should be positive, right? So A should be 4, B should be 4 pi, and D should be 5. C should be negative 7 over 8, right? Alright, let's move on to the next one right here. Within the interval T1, T2 of G and J, right? So I look at G and J right here. Right? And look at the y value right here. The y value is positive, right? So the function is positive, right? And then it's going down, which means it's decreasing, right? So h is positive and decreasing, the answer must be B, right? Now, the last one right here. Within this interval, the function is concave up, right? And the rate of change is increasing because the function is concave up, right? So you need to write the function is concave up and the rate of change is increasing. And again, you need to write this one in a complete statement like what I did in the previous examples, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us high.